All right, hello everyone. Welcome back. So as I said, the plan right now is going to be to get everyone set up on Scholar, just so that we have that out of the way, hopefully. And Mitch is going to go over that. And then once we finish, hopefully that won't take that long. And then once we're done with that, we will come back to finish up the slides. Okay. So I'm not sharing, so I think then Mitch, you can go ahead. And this is being recorded, so I'll post the video later.
I think you have the sharing disabled.
Do I? Okay.
Yeah.
Okay. Okay, I think I fixed it now.
Yep. All right. Let's go ahead. Okay. Can everyone see my screen?
Yes.
Okay. I'm going to put a link in the chat. If everyone can open that, we can get started. Let me know when you guys are good. All right, so once you get to this link, this is kind of the main link you can go off of, so I recommend saving it. From here, go ahead and click Remote Desktop, the launch button. From here, log in with your username and boiler key, so in my case, Berkham. All right. Once you do that, a screen that says "Welcome to Scholar" will come up. That just tells you some information about the system. Don't really need to pay that too much attention. Just go ahead and click OK. All right. So now we're in the main, basically Linux OS. I went ahead and made some files. Those are the ones that are zipped on Blackboard. So go ahead and just open up a browser. Just log into Brightspace like you normally would. Go ahead and download that zip file. All right. So to unzip that, you can just go to your downloads directory on terminal. Just type unzip and then the file. That'll unzip everything into the directory files for students. So go ahead and CD into that directory.
Mitch?
Yep.
I get into something. Welcome to Scholar, nodes, A and G. Is there do I have to click on something here or just hit the X?
I should just hit the X. I don't know what that node is.
It keeps disconnecting me. I don't know why. So the address was https www.rcac Purdue Compute Scholar, correct?
Yep.
I'm running this from my Mac. It should work on the Mac.
Yeah, it should.
And then remote desktop, correct?
Yep.
Yeah, I click on launch. The username is just your, should it be your email or just your user?
Just the username.
And then boiler key, correct?
Correct.
That's what I've been doing.
Yeah, I'm getting whacked. It's telling me the boiler key's wrong.
I get to the screen that says, welcome to Scholar. Scholar consists of notes, Scratch, Qt, software, user guide, help. And then I don't see anything else, but when I hit the X, it's kicking me out for whatever reason. Yep. And it just says, go to the login page again. Maybe I'm going to try this on the Windows machine.
No, same with me. I'm trying that on Windows, but it's like same for me too. When I'm clicking the X, it's disconnecting me.
Yeah, it does the same for me.
Is everyone having that
some
problem?
Some of you
Yeah.
that were successful.
I'm in.
Yeah, no,
Mine's
I
working.
got in as well.
Okay. Let me try it again.
Is there a limit to how many people can be on?
There shouldn't be.
Yeah, we're all registered, right? That was the whole.
Yeah.
I get to the blue screen. I get, oh, there's a button there. Okay. I think that was the problem on my Mac. I wasn't hitting that okay. I just didn't see it. So use default config or one empty panel.
Just use the default.
I'm in now. So
Okay.
how many people are not in? If you can identify yourselves, please.
We are not in. Me not in.
Me too. I'm not in.
So 2 people.
Joe.
Are there any more?
Joe's not in.
Who?
Joe.
Joe is also not in. Is that somebody that wrote on the
Yeah.
chat? So there's 3 or 4 people. So click on if you're on Windows, click on the link, right, Mitch? And then remote desktop, try it, type in your boiler key. So I guess let's do this. Email me and Mitch, and just, we're recording this video. Try to follow along meanwhile.
Yeah, I added everyone to the machine, so
And
they're
we'll figure it out. But let's, I guess, just continue and see if we can get at least a lot of people in, and then maybe it's just a little problem. All right, so I'm also in, Mitch. And then once we're there, right, you said to open a browser here?
Yep.
Where do you find a browser on this?
at the top left in applications, you can go to web
Okay.
browser.
There's a web browser. Okay, yeah, I see it. And then just okay?
Yep.
No application selected? Okay.
Should be Firefox.
Okay. I have to select it explicitly. Okay. Not doing anything. Okay, it's just slow maybe. All right, so then now you said go to Brightspace, right?
Yep.
Okay, and then once you're on Brightspace, download the folder that I posted, or
Yes, the zip file.
okay, yeah. So that one was under resources, I believe. Okay. Is that in where? So now, okay. So after you download, go to file system.
Yeah, so just open up a terminal, then CD to downloads.
Okay, so then a terminal. I assume that's also in terminal emulator. Okay.
Yeah.
Right. And then go to download.
You should see the zip file, so just go ahead and type unzip, and then the zip file.
All right, so unzip. Are they seeing what you're typing or what I'm typing?
What I'm typing.
Okay. So unzip it. All right.
All right. That should create a directory called Files for Students. Go ahead and CD into that. All right. Once you're in that, go ahead and run the following command for bash and then commands.sh. This shell script will install Anaconda for you automatically. So once
There's
that,
no sudo or anything here, right? We just have but we have permission to do these things.
Yep.
Okay, bash and then commands.sh. Just that.
Yep.
Hit enter.
that'll download Anaconda, and right away it'll take you into basically the default configuration of Anaconda. So just go ahead and follow along with that. Just hit enter.
Hit enter.
Just hit space a few times to get through all that. Just to accept the license, go ahead and type yes to the license terms. And then it's going to tell you to specify the directory for everything. I'm not going to specify it because I already have it configured. But basically from here, just follow along with the default, just the default configurations of Anaconda.
Press enter.
Yep. When you guys are done with that, go ahead and let me know, then we can move on.
What was that command again you did for the zip file?
Just unzip and then the zip file name.
Okay, cool.
So it's still unpacking for me. Does this take a while?
It shouldn't take too long.
So maybe for those of you that don't know what Anaconda is, maybe Mitch, you want to just give them a little.
Yeah, so basically it's a good package manager used by a lot of data scientists. So it comes pre-installed with a lot of data science tools, and allows you to install them. For example, TensorFlow, PyTorch, the common ones, NumPy and Pandas. Those are already pre-installed. It also comes with 2 IDEs, Jupyter notebooks, so it's a little different from a normal IDE, and Spider, which is basically your typical IDE.
Hello?
Yep.
And then once we do this, every time we log in now, it's just there, correct? It's just
Correct.
So basically, these instances throughout the semester are for the students, so their data will be there.
Yeah, it's all local to their account.
Yeah. So just make sure, though, you do back up things just in case, as usual. But hopefully, everything, your scripts that you write, your code should remain there.
Yeah, and to move it out from here to just your local machine, you can probably just go ahead and just store it in the Google Drive so you can access it from outside.
I still have a problem with your password or login. Can you please tell me what is your login and password?
It's exactly what when you get to Brightspace, right? So the same way that you get into Brightspace, that's the same way, correct, Mitch?
Yep.
So if you get to Brightspace, whatever you do there, that's what you should be doing on this.
If it's not working, go ahead and send me an email and I'll take a look at it when class is over.
And this video is being recorded, so I will post the video. Okay, so for me it says, warning, installation finish. You currently have a Python path environment variable set. This may cause unexpected behavior. Do you wish the installer to initialize Anaconda 3 by running conda init, yes or no?
Yes.
And I think, thank you for installing Anaconda, so that's, I'm in the prompt now.
Yep, so go ahead and close the terminal out and just open a new one just so it can accept the changes that you just made.
All right, so now open another terminal. All right, in there.
All right, once you're in there, go ahead and go back to the downloads folder.
Okay, are you taking Bradley to mow the lawn?
Brad, go. Guys, can you mute your microphones if you're not listening?
All right. So once you're in the downloads folder, go to the files for students like you were before. Just go ahead and type bash and then hit enter. That'll activate bash terminal basically. The terminal's not set in bash, but that's where Anaconda installs. So
Just type bash.
yep, and then hit enter.
Okay.
So now you'll see this little thing for base. So that is Anaconda's base environment. So basically, when you install Anaconda, this will tell you what environment you're in. You could have multiple virtual environments just for different versions of packages.
Right. So one example, for instance, of what Mitch is saying is that in TensorFlow, there's TensorFlow low-level API, and then there's TensorFlow high-level API. And, that depends on, versions like 1.15, let's say, versus version 2. So what Mitch has done is he's created 2 environments, one for TensorFlow 2 and one for TensorFlow 1, what is it, 15?
Yeah.
Yeah. And so that way you will have two environments, and that's really the best way when you're using Anaconda and in, you know, machine learning, AI. You really sometimes you will need the same set of programs or libraries, but different versions of it, depending on the task that you're doing. Okay, the different things that we're learning. And so that's what he's going to talk about right now, is that you have this base environment, but you're really not going to use it. Instead, we're going to have these two different environments, and we can use either one depending on the problem that we have.
So to install those, I already made them for everyone. So just to save time, go ahead and cat the requirements for TF1 file. Actually, never mind. Don't do that. Go ahead and cat the instructions file. There we go. Number 9 is the line that'll pop up. So basically, you just want to go ahead and grab everything that's in the quotes for conda create -n. Just copy that just to save time.
Line 9.
Yes. Yep, and then just take everything that's in these quotes. So conda create. So go ahead and copy that and paste that and hit enter. So this will create one environment for TensorFlow 1 and everything else we'll need, and it's labeled as such.
I get an error. It says requirement, no such file or directory requirements for TF. Is it a typo maybe?
Are you in the same directory that's in the files for students?
Yep.
It looks like updated is added on to this text file that's in the folder, while the one in the line 9 doesn't say updated.
Oh, that's right. You see that, Mitch? You added after TF1 underscore updated.
Where at?
Inside the
Files for students, the line 9 just says requirements for tf1.txt, but in the folder where you have commands and instructions, the files are actually called requirements for tf1 underscore updated.
Ah, okay. Yeah, so go ahead and just do that one.
The underscore updated for TF1?
Yeah. And that should create, and just go ahead and hit enter on once you're done with that. That'll create the environment. Just to check.
Hit yes, proceed, hit yes.
Yep. And that's going to install all the packages that are in it. May take just a little bit just for TensorFlow and some of the larger packages. Once that's done, everyone can go ahead and run the following command just to verify the installation.
So this is installing TensorFlow 1.15. Note there, and pip, and pandas, and SciPy.
So I'm inside the files for students. I did that conda create, and it's just bouncing it back to me saying command not found. I did the whole updated at the end of it.
Did you enter bash?
Yep.
That's odd.
I'll keep trying with it, messing with it, but I'll try hitting bash again and see what happens.
Yeah, just make sure you see this, the little base environment before your name.
Okay, there we go.
Okay.
So this finished for me. I'm back in the prompt of the base.
Okay. Go ahead and run the following command that's highlighted just to make sure it got installed.
So maybe ask everyone if guys, did it finish installing for you as well, for most of you?
No, sir.
Not you, right? We know you have a problem. Everyone else?
I got mine going.
Okay. Josh, Thomas,
I'm good.
good. Sydney,
I'm still running the installer, but it's working fine.
okay. All right. So some of Mitch, can they see? Because I know you had it already. So are they seeing you typing the commands or no?
Yeah, when I'm typing them.
Okay. So they are all right. Because I know you had it already, so I wasn't sure if because in the video, are we gonna be recording it? You know what I mean?
Yeah, you could see it.
Okay, great. All right, so on mine, I assume you have Conda activate. Is that what you have?
Yep. So just to activate the environment, just you can check with this conda info --envs. You'll see at this point, you guys will only see the TF1 and base. That's fine.
So Conda environment list, is that the one?
Yeah.
Okay, so Conda environment list gives you the number of environments you currently have. Yeah, so for me, it shows base and it shows ITS 520 TF1, right?
Yep.
Yeah. All right. So
at this point, you can just go ahead and retype the command or just hit up a couple times until you get the conda create command again. And just change
the other one, you mean? But
Yep.
I just want everyone to know that if they want to get into the environment, that's where they would type conda activate ITS 520 TF1, right?
Yep. And then it'll change on the left accordingly.
Right. So if they are successful, and you have that environment, so you can show them when they type that, the base is going to go away, and now it's going to look like ITS 520 TF1, right?
Yep.
Yeah. And so that means you're in that environment when you see that. And so the libraries that you have associated are the ones with the versions that we currently just installed. Are there any questions about this? It's important that you understand that this is what we were doing is to get to this environment. So this is when you're doing some homework assignments, maybe we'll say, okay, do it on TF1. So then you'll come to this environment and run all your code. Now the file structure doesn't change. It's just the associated libraries that change. Any questions about that? Okay, so then now we exit with conda deactivate, right?
Yep.
Okay, and now we're back on base. And now that we're back on base, install the other one.
Yep. So it should be the same command, just change the TF1 to TF2.
right? And if we do ls-l, we can see it. So then, okay, up arrow to conda create -n, but we have to change now what?
Just the number from TF1 to TF2.
Right, so conda create -n its520 TF2, and that's going to be the name of the new environment. So very important so that you don't affect the other one.
And then in the requirements, just change that file name to TF2 as well.
Right. So then --file requirements _for TF2 updated.txt.
Yep.
And so now we can go ahead and just hit enter. Right?
Yep.
All right, and it'll do the same thing. We're creating the second environment. This one will have TensorFlow 2. Congratulations, you guys took this class. Oh, hit yes there. At the right time when TensorFlow 2 just came out. When was it? Like last year?
Yeah, I think so.
Yeah, so TensorFlow 2 is out. It's a new rewrite of TensorFlow 1, hopefully to be more Python-y and user-friendly. So the way I see it is that this is more of a top-down approach, whereas TensorFlow 1 was more of a bottom-up approach. And so we're going to take, I actually want to contrast both this semester, but in essence, we'll be looking at TensorFlow 2. Are there any questions, guys?
I don't think so.
All right, good. So sklearn was installed in these, right? Mitch?
Yep. Yep.
Matplotlib.
Should be. Yep.
Okay. If not, we can always add a library
Right.
as needed. And this is probably Python 3.5 or above, I'm guessing.
Yeah, I think it's 3.7. I set it as.
Okay, great.
Why is this?
All right, so it finished for me. So once again, so are they seeing your base again?
Yep.
Okay, so maybe just walk them through again for completion.
Just make sure it's installed. Go ahead and type conda info --envs. That'll show you all of the environments, and it'll put a star next to which one you're active in. And then to activate it, go ahead and type conda activate, and then the environment name. So in this case, just to show a change, I'll show TF1. And that'll change. So you could do that for any environment you want, and you'll get in and out. And just to show you guys that there are, in fact, different packages, you can go ahead and just look at the screen. You guys don't need to run this, but so in the TF1, we have TensorFlow 1.15, and in TF2, we have TensorFlow 2.2.
Excellent. Any questions? So guys, I'm looking at the participants list. Can you there's a button in there where it says raise hand. Can you just click on that, raise your hand, and that way I will know if you're if you installed both of these successfully. That is, you were able to get to what Mitch has there of the, he can get into both environments. So can you just raise your hand, and that way I will know how many of you got it to work? Please. Or at least if it's still installing, that you're, maybe TensorFlow 1 is there, you're still installing TensorFlow 2, but just give us a little statistic there where everyone is. Guys, I only see some of you.
I put mine in chat, yeah.
Don't put it on the chat, please. Just do the, on the raise your hand, so we can just get a quick overview of everyone. Guys, so everyone else? Sydney?
Oh, sorry, I'm done. I finished.
Just help us out, because otherwise, we want to get a picture of how many of you are still having problems. So I'm just gonna do like, Shang-Chi, Dikshita, Harika, Joe, Sydney, Sihao.
Yeah, I can hear you.
You can hear me? Are you guys having problems with this, or?
I don't know why I need the root to install the Anaconda.
You don't need anything. I mean, you just have to follow kind of what we were.
He said the permission denied it.
So,
yeah, denied.
did you type sudo in front of something? I mean, you just have to type the commands as.
I tapped the command, but he said permission denied. So I tapped sudo. He asked me to tap my password for my account.
Okay.
So I will review the video.
Yeah, so let's do that. So we're recording the video. Okay, so some of you are just saying, and some of you are just writing on the chat, but you can just raise your hand. All right, anyway, so some of you are saying that you're just gonna want to review the video and then do it, so that's fine. So try it, please. And if you still have problems, then email me and Mitch, and we'll try to help you, but it's straightforward in a sense. So hopefully it'll work.
Can you please upload the instruction of this? That will help. We can go watch the video again. But
right, so I will post the video. I can't post it now because we're still, but I will be posting this video.
In the zip folder, there's the instructions.txt file, and that has step-by-step guide.
okay.
That's the one that's zipped on Blackboard or Brightspace.
Yeah, so the download is on Brightspace, yes, under resources. All right, so definitely, once I post this video, please definitely review it, follow these instructions. You only have to do this once, and it'll just make your life a lot easier if you have both environments. So that way, or you can create, as you become better with Anaconda, you can create more environments. I suggest it's always better to create a new environment versus, start modifying the libraries that you have here. So be very careful when you're in an environment and you say, oh, I'm gonna pit this or, install this or that. It's probably better to create another environment, do your processing, whatever you need to do on that environment, have the file, and then run it on here, okay? Because what you don't want to have is this problem that you break something because there's a compatibility issue, okay? And as I said, it's currently the way data science is, all right? You have to get into this habit that sometimes you use different versions of the libraries. Right? But Anaconda is very good at this, and it's the recommended approach, okay? Remember, you'll have your local Windows version, Linux, Mac, and you just have this, and the advantage of this is that you have the GPUs. So Mitch, I don't know if you can show them that we have GPUs on here. Or...
Yeah, so let me go ahead.
And that's really great because remember, when you have GPUs, we are now doing machine learning AI in parallel. And that's a different thing. Because it speed ups things.
Okay. Why is... That's odd.
No, that's correct. Just do print. So do you did session run X, and X is TF constant. So just put that in a print statement because it's only showing right now like the data type. You have to, yeah.
So let's do that.
Yes. You were missing a parentheses.
Yeah.
Right. So there's it ran, and then here though.
It says CPU, which that's...
Yeah, that's what it should have said, show the GPU, right?
Yeah, let's try that again.
Because these by default should have access to the GPU.
Failed to call. That's odd. Wonder if there's something wrong on the Scholar end.
I don't know.
Because that was the same command that we checked to
Right.
at the other time.
Mm-hmm. I'm trying it on my end too. See, it worked for me, Mitch.
Okay.
So let me just quickly share my screen, right?
Yep. Let's see. Let me stop.
So are you guys seeing my screen now?
Yes.
Okay. So if you look over here, it says Tesla V100. So PCIe, which is a GPU, the GPU connections. And so you can see it's basically, when I ran the TensorFlow command, session run over here, and don't worry about that, you don't need to know that, but the Tesla V100's PCIe, well, Tesla is an NVIDIA card. That's pretty good. I thought this said P100. So I'm not sure which GPU we have, but you guys can certainly probably dig deeper and figure out. But usually when it says that a GPU has been detected, and the CUDA library by default, it's going to do the processing with the GPU. Does that make sense, guys? Did at least some of you get this? If you try it, guys? No? You guys still there? Did you fall asleep? All right.
Yes, my mic was on mute. My bad.
Say that again, sorry?
Yes, my mic was on mute.
But you got the GPU Tesla information?
Yes.
Okay, excellent. So at least some of you are getting this. As I said, don't be overwhelmed. We'll have the whole semester to play with this, but at least now we have a video. Most of you have gotten into the environment or are in the process of installing it. If you on your own laptops, Windows, Linux, Mac, you can also install Conda. It's the same thing. The only difference is here on the Scholar website, we have access to actual GPUs. So really, if you're doing a big data class, you can't really process without it. Remember, I think I mentioned this, when we talk about parallel computing, it's either GPUs or Hadoop, which is CPU clusters, which you probably remember from 372. But in this class, we're only focusing on parallel computing via GPUs. I have a question. When you write on here, let's see, I don't always see it. All right, are there any questions, guys? Mitch, do you have anything else?
Nope, that's it for me.
That's it. All right, are there any questions from you guys? Questions? All right, and then to exit, Mitch, is there a specific process to just exit out of Scholar or anything in particular?
Yeah, go to the top right of the screen and just go to click your name and click log out.
So I guess my question is, do we leave the machines like running? Do we have to shut them off? We can't shut them off, or just log out basically?
I don't think we have permissions to shut them off, so just log out.
All right, so where your name is, so not suspend, not shut down, just log out. Yeah?
Yep.
Okay, that's what it's, all right, so it's showing for me log out. We will double check on this to see which one is the appropriate one, but for now, let's just log out. And then it says hibernate, restart, shutdown, suspend. So just log out. And then it closes everything and you're just back to your regular browser. Okay. Great job, Mitch. Thank you very much. All right, guys, so everyone's really quiet, but I assume there are no questions since I'm not hearing anything, right? Okay, so as I said, you know, hopefully most of you got this to work. If not, just watch the video again. Hopefully that'll help a lot. And if you still are having problems, then definitely email both me and Mitch, and we'll try to figure out what's going on, okay? All right. So now let's go ahead, get back to the slides. So we still have about half an hour. We can wrap up the slides, and please go ahead and ask any questions you may have. All right, so where did we stop? I think the last thing we looked at was what? Recall, right? So we were talking about recall. So who wants to summarize accuracy, precision, and recall? Anybody want to do that? No? Okay. Are you guys still there? Can you hear me? I sometimes become like paranoid that you on. Somebody there?
Yeah, we can hear you.
Okay, great. All right, so we were talking about precision recall and F measure. So let's just recap here under recall. So the precise definition of recall is the number of true positives, right, divided by the number of true positives plus the number of false negatives. So best way to understand recall, looking at it over here, I think intuitively, you know, terrorist correctly identified and terrorist incorrectly labeled as non-terrorist. So basically, it's all the actual terrorists, right? So that's recall, all the actual terrorists over there. Okay? So by the number of true positives plus the number of false negatives. So recall then, scratch that. All right, so how can we find all terrorists? In this case, let us predict everyone as a terrorist. Obviously, if we do that, if everyone is labeled as a terrorist, we solve the problem, right? We found them. The recall will be high because we found all, we didn't miss anyone, but then there's a problem with that. In the case of recall, when we increase the recall, we decrease precision. So we have high recall, we found everyone, but the precision of all that we found is not very good. Again, we intuitively know that a model that labels 100% of passengers as terrorists is probably not useful. Remember, the number was 800 million. You don't even have the resources to investigate that many. So it's probably not useful because we would then have to ban everybody from flying. So that doesn't work out. This approach then therefore suffers from low precision. We found everyone, but it's basically, you know, again, garbage because we can't do anything with it. Or the ability of a classification model to identify only relevant data points. We didn't succeed with that. So that takes us to precision over here. And again, we go back to our little table of true positives, false negatives, true negatives. And so precision is defined as the number of true positives divided by the number of true positives plus the number of false positives. This one. So if you remember, recall looks like that, right? Precision looks like this, which is similar to what we had discussed initially, right? So again, precision is defined. You know, sometimes you have to look at this a couple of times. Maybe you create your own cheat sheet. Precision is defined as the number of true positives Is that a question? Mhm. Did someone have a question? Okay. All right. So what was I saying? So precision is defined as the number of true positives divided by the number of true positives plus the number of false positives. So you can see that here. And the way I think of it is, then if it's this, is the predicted. So precision is related to the predicted. Out of the predicted, we want a number. Okay? So false positives are cases the model incorrectly labels, because it's the predicted, right? So it's going to predict both true and false. And so false positives are cases of the model incorrectly labeled as positive that are actually negative. Or in our example, individuals the model classifies as terrorists that are not. Precision expresses the proportion of data points our model says were relevant and actually were relevant. So again, the best way, I think, intuitively to think about this one, precision, is to think of it this way. So here we have terrorists correctly identified. The model said those are terrorists and it was correct. And also the model says individuals incorrectly labeled as terrorists. So everything the model predicted as terrorists, and then versus the terrorists that were actually terrorists, correctly identified. So now we can see that our first model, which labeled all individuals as non-terrorists, wasn't very useful. That was accuracy. So hopefully that makes more sense. Although it had near perfect accuracy, it had zero precision and zero recall because there were no true positives. We can modify the model slightly and identify a single individual correctly as a terrorist. Now our precision will be zero, no false positives, right? We didn't have anything that was a false positive, but our recall will be very low because we will still have many false negatives. Okay, so if we go to the other extreme and classify all passengers as terrorists, we will have a recall of 1. We'll catch every terrorist, but our precision will be very low and we'll detain many innocent people. So that doesn't work either, right? So that's why, in other words, as we increase precision, we decrease recall and vice versa. And so you can see it's really a game between the two. They're related somehow, right? And sometimes it turns out that it's better to look at precision. Sometimes it turns out that it's better to look at recall, depending on your problem, right? But the F measure now is the one that combines both precision and recall. So in some situations, we might know that we want to maximize either recall or precision at the expense of the other metric. And here's, for example, the classic example of this is in preliminary cancer screening of patients for follow-up examination. We would probably want a recall near 1%. We want to find all of them. We want to find all patients who actually have cancer. And then we can accept a low precision on this problem because especially if the cost of the follow-up examination is not significant, right? So we can afford low precision, but we want to have almost perfect recall because if you miss one case of cancer, that's death for someone or further illness. And so that's kind of the idea. However, in cases where you want to find an optimal blend, and that's usually what we try to do, that's why people mostly don't look at recall or precision, but focus on the F measure. However, in cases where we want to find an optimal blend of precision and recall, we can combine the two metrics using what is called the F1 measure or F1 score. So you can see the F1 score here. The F1 F1 score is defined as a harmonic mean of precision and recall, taking both metrics into account in the following equation. You can see that. And that's really what's happening here is the F1, you know, it's clear and obvious from that formula that the F1 measure is taking both into consideration. So you might be asking yourself why. And so just intuitively, we don't have to get into all the details, but just intuitively can understand that with F1 measure, we use the harmonic mean instead of a simple average. Because we could have taken the average of precision and recall and kind of, if it was, you know, if precision and recall 1 and 0, or 0 and 1, or 0.5 and 0.5, right? And we could have taken the average of both and just come up with a single score. But it turns out that doing it like this formula, which is, as you can see, it's not exactly the average, is called a harmonic mean. And basically because the harmonic mean, because it punishes extreme values, okay? So the F1 measure will punish when you have an extreme difference. A classifier with a precision of 1, right, and a recall of 0 has a simple average of 0.5, right? You guys, you know, take the average of that as 0.5. But the F1 score will be 0. So the regular average is 0.5, whereas the F1, you know, it's 0 using that equation. So the F1 score gives an equal weight to both measures. Okay, and so the idea being that it should in some way not penalize, right? Not penalize something. You know, 1 times 0 is 0, makes everything 0. 0 times 1 is 0, makes everything 0. But otherwise, you know, 0.5, 0.5, and so on. So it's just, it basically intuitively what you have to understand is, you know, 2 ideas. First of all, that it combines both of them, and then intuitively also this statement here. The F1 score gives equal weight to both measures. So it punishes, and this really punishes extreme values, okay? So it doesn't want one where, you know, that's too extreme on the precision side or the recall side. It kind of wants a more balanced result. There are other ways of calculating this. There are other metrics for combining precision and recall, such as the geometric mean of precision and recall, but the F1 score is the most commonly used. Okay. You can disregard this. We're not gonna, so really just, you know, that's the definition. If we want to create a balanced classification model with the optimal balance of recall and precision, then we try to maximize the F1. Okay, so that's going to be our goal. It's really to try to maximize that metric there. So performance evaluation. So now we're finished basically, so hopefully that made sense. Our discussion of the difference between precision and recall and F1 measure. Okay, and so hopefully you understand that sometimes, like in cancer detection, you'd probably, or terrorist detection, you'd probably want a final recall. And then even though if your precision suffers a little bit. However, when you want a balance of both, you probably want to look at the F1 measure. Are there any questions so far? All right, so it seems there's no questions, so let's keep going then. So let's go ahead. So performance evaluation of the performance of classifiers is extremely important. The sklearn kit provides very good modules to address this issue. In particular, evaluation often involves measuring accuracy, precision, recall, and F measure. All right, and that's really what I'm going to ask you guys to always do, is you will always just represent or present the results of all of these metrics. The best way to understand these metrics is to think of a confusion matrix. I think that makes sense. That's what I've been discussing so far. Confusion matrices show how many elements from a class are correctly or incorrectly classified. And here's the code. So this is basically your first presentation of code. This will be using sklearn, as we will start learning shortly, the sample code to obtain the metric. So as you can see here, I just created a function. I call it printstats percentage train test. It's just my little function. And then notice it takes 3 parameters, of which this one you can disregard. That's just if I want to add some data in there. But what's important is for supervised learning, we always have those 2 arguments. And I really like to call these Y test versus Y pred. And what that means is the Y test sample, the real label. Oops. So that's the real label versus the predicted label. So remember, this would happen in the context of the model. So the model, you have a model, right? And you train on the train set, right? And then you apply the model to the test set. And what you know about this test set is that you have samples in there with their labels. That's this. But then the model will disregard the labels, just take the features of the train set and predict the label. That's what it's going to be called, Y pred. So for instance, this would be Setosa, right? Setosa is the real one, but the model predicted versicolor. Oops. So in that case, what do you have here? That's an error, right? So that's an error. It didn't. So when you're calculating things, now you're going to put this in the confusion matrix, and you're going to figure out your precision, your recall, and your F measure. So these are the parameters that we always use. We're going to use them throughout the semester always for supervised learning. Then after that, don't worry about the code so much right now, but you can see we have a few print statements, and pretty much the standard approach is that we call a module called accuracy score, or a module called confusion matrix, or a model called precision, recall, and F1 measure. And if you notice, the inputs to them are Y test, Y pred, Y test, Y pred, Y test, Y pred, Y test, Y pred, Y test, Y pred. Right? So we always come up with those values, right? We feed them into this equation, and this equation is going to give us our metrics very much like all right, so it's going to be very much like what was I saying? Lost my train of thought there. What was I saying, guys? I'm sorry. So we were talking about Y test and Y pred. Oh, I remember now. So we call the accuracy score, the precision score, recall score, F1 measure score, all of these. And this is basically very much like what you get with WECA. Okay, so very much like what you get with WECA, only now we're going to be doing this with, in Python with our libraries like sklearn, Tensorflow, and so on as we move forward. But this is very important. Now, definitely read through this script. A lot of things like, this is just format strings, right? So precision, recall, all the format strings. And so you are going to be reusing this function every time. Questions? Okay.
Nope, I'm still here, but no.
No questions? All right. All right, so as you can see here, the code explanation, the code above shows a function to print the performance metrics, and then two sets are provided of data, ypred, ytest. Keep in mind, guys, one important thing is going forward, whenever we talk about a variable, you know, we mean a variable that's actually not just one thing. So you might imagine it's like 0.5 and 0.4 and you compare those. But going forward, things are actually vectors and matrices. So what that means is that they're sets, and that's why I wrote sets there. So ypred, ytest, right? And then you have just, you know, maybe 1, 2, 3 until n. And so you got, you know, 0, 0, 1, 1, 0, 0, 0, 1. So you have one error, but it's not variables anymore, but sets of variables, which we're going to define as either being vectors of data or matrices. Okay? So that's an important, and that, again, that will become a lot obvious. That's why we're going to do the NumPy exercises. So you will definitely get a feel for what we're talking about. Okay? The ytest dataset contains the original annotated labels. The ypred dataset contains labels predicted by our classifier. Okay? Each of the metric functions, such as F1, recall score, uses these two datasets to calculate the respective metric. So as you can see now, these ytest and ypred are actually vectors of all the data. So it might be, for instance, for iris, your entire test set, right? So if we had 120 samples for training, then we had 30 samples for testing. So these were two vectors of size 30, 0 to 29, or 1 to 30, if you want to think of it. And the only thing is they need to be aligned correctly. But usually the way the programs are written, that's very easy to do because we are no longer going to start using like for loops and everything. We're going to be switching to a different kind of an approach. All right. Okay, so code explanation. All right, so that's it. That's the performance metrics. We are done with that. Glad. All right, and so, in conclusion, we looked at precision, recall, F measure, confusion matrix, right? Accuracy, of course. And that's, the main set of features that we will be using this semester. Okay, so that kind of concludes today's discussion. The next topic would be to look at the next set of features, but we probably have to run out of time for today. Yeah, let me switch over to table of contents. All right, so as you can see, we are done with performance metrics. This one, in the next set of next class, next Tuesday, we will start with data sets and features, and probably we will get into NumPy arrays. So make sure you get your Scholar working. So that's no homework this week. Just make sure you get that going. And then we will, or also have it on your Windows and Linux, Mac, install Anaconda. And then I will next week, probably in the lecture, just go over these dataset features. And then in the lab, I will start doing like NumPy array exercises and just, go from there. So you'll probably, you'll see more. I've kind of given you a hint at this point of where we're going with the data. But anyway, that concludes our discussion for today on performance metrics. And also, thank you to Mitch for such a great job in getting Scholar to work. I honestly thought this was going to take longer, so I'm really glad we have that resource. Okay, Mitch is going to help us all semester with this, so if in case there's problems and things like that. All right, so are there any questions?
I have a quick question about the homework.
Yes, please go ahead.
When we're doing the multi-layer perceptron, how long is that supposed to take?
How long did it take for you? And first of all, which data set are you talking about?
The smaller MNIST.
Smaller MNIST, right? I'm glad you asked that question. So smaller MNIST is how many samples? Like
It's 10,000.
10,000. 10,000 by 784. You run it in Weka with multi-layer perceptron. How long is it taking?
I started it an hour and 20 minutes ago, and it's still building a model.
Still building a model. How long did it take for Iris, would you say?
Like less than 5 seconds, probably.
Less than 5 seconds. What's the difference between both? The Iris data set is 150 by 5, correct?
Yeah.
And MNIST is 10,000 by 785.
Yep.
That's the size of your matrix, the one that you just told me. If you were using train set, it would be 60,000 by 785. So imagine how long it would take with that.
Yeah,
right?
I don't know if it's working correctly. I think it is because the other ones run.
Weka is easy. You just, hit a few things.
If you look in the bottom right corner, if the bird is still moving, you're good.
Yeah.
So I just have to wait for.
Is the bird still going?
Yeah, the bird's still going.
So why do you think that I make you do this?
So we understand the differences between the classifiers.
Well, just multi-layer perceptron in particular.
To torture us.
I mean, yeah.
Is what?
Torture us.
Not torture you, but to show you that MNIST is tiny compared to big data. Big data is not 10,000 samples. Big data is 2 million samples. Do you see that? So imagine if you were doing 2 million samples with multi-layer perceptron on Weka, which is a CPU. And it's not that I'm, bad-mouthing Weka. Weka is great. It's the fact that we're using CPU. Are you using your Windows machine or are you using a VM?
I'm using my Windows machine.
Yeah, so I'm sure you have 8 RAM or somewhere along that. But the lesson here is that just because you have a great algorithm, if you don't implement it correctly, you're not really accomplishing much. Before 2007, people could only do what you're doing. So you can see how machine learning and AI was stuck, right? You could really not do much. That has changed now with parallel computing. That's the reason why instead of doing multi-layer perceptron on Weka, we're going to be doing deep neural networks in Tensorflow. Because as you saw in that class, we're using GPUs. That's going to be orders of magnitude faster because of the parallel computing. So in a way, it's a reason to motivate why, we are going to do what we're going to do. Does that make sense, Kyle?
Yeah, I'm just worried about it finishing before I have to turn in the lab.
Don't worry about it. I mean, I don't expect you to, on multi-layer, do the other ones for sure. On multi-layer, I expect you guys to tell me it took forever.
Okay.
That's the whole point, because it illustrates that you're not being, I don't want you to go to an interview and say, oh yeah, I'm just going to use multi-layer perceptron on my CPU, with 10,000, and that's not big data. It's not the right approach. What you're going to say is, I have 2 million. I'm going to use a GPU. I'm going to use TensorFlow. I'm going to, and a lot of other things that are going to allow me to learn. We're going to learn how to program differently a little bit, okay? A different way of thinking when we're talking about parallel computing and big data itself. Does that make sense?
Yeah. Can you make Weka use a GPU or no?
I believe so. I believe I've read that they've adapted it I mean, the whole country of New Zealand stands behind Weka. So they certainly have extended it. So as I said, it's not about bad-mouthing Weka, it's about Weka on a CPU is limited. Do you see that?
Yeah.
But Weka is just software. New Zealand, with enough money, they will make it parallel, no problem. Right?
Yep.
Okay, great. So yeah, that's the lesson there. Hopefully that makes sense. It's just to motivate what big data actually is. You will always remember that 10,000 on Weka on CPU is not big data. I need to learn something. All right?
Yeah, definitely.
Great. Yeah, great. Excellent. So we're going to stop here for today, guys. And I will create the video and post it. And to Mitch, again, thank you very much. Great job. So I will see you guys next Monday.
See you next Monday.